The traction control system warning light is a critical indicator that tells you about your vehicle's traction control status. Understanding what this light means can help you identify potential issues before they become serious problems. There are two main states for the TCS warning light. A solid light indicates the system is temporarily disabled, has detected a malfunction, or has been manually deactivated by the driver. A flashing light means the system is actively engaged because the wheels are slipping. This is normal operation during low traction situations and should stop flashing once traction is regained. Modern vehicles now feature advanced diagnostic technologies that make troubleshooting TCS issues more precise and efficient. OBD3 integration provides enhanced diagnostic capabilities with more specific fault codes. Wireless diagnostic tools now offer real-time monitoring through smartphone apps. Some premium tools even use AI to predict failures before warning lights activate. As of 2024, all new vehicles under 10,000 pounds are mandated to have electronic stability control, which includes traction control, as standard equipment. Now let's examine the most common causes of TCS warning light activation based on industry statistics and diagnostic data. Faulty wheel speed sensors account for 65% of TCS issues, making them the most common failure point. Damaged wiring and connectors cause 15% of problems, while ABS control module failures account for 10%. Less common causes include low brake fluid at 5%, steering angle sensor issues at 3%, and other electrical problems at 2%. Let's examine the key components involved in TCS operation, starting with the wheel speed sensors that monitor individual wheel rotation. The ABS control module processes sensor data and controls brake application. It shares components with the anti-lock braking system and has a failure rate of 5 to 10% of TCS problems. Electronic stability control, which includes traction control, helps maintain vehicle stability by detecting understeer and applying selective braking to individual wheels to keep the vehicle on its intended path. Understanding these components and their failure patterns helps in proper diagnosis and maintenance of your vehicle's traction control system. When troubleshooting a TCS warning light, start with basic checks. First, verify tire pressure is correct on all four wheels, as uneven pressure can trigger false warnings. Next, check the brake fluid level in the master cylinder reservoir. Low brake fluid can cause both ABS and TCS warning lights to activate. Use an OBD2 scanner to retrieve diagnostic trouble codes. Connect the scanner to the diagnostic port, usually located under the dashboard near the steering column. After retrieving codes, clear them and perform a test drive. This helps determine if the fault is intermittent or permanent. Intermittent faults may not return immediately, while permanent faults will reappear quickly. If wheel speed sensors are faulty, they need replacement. Sensor replacement typically costs between $150 and $400 per sensor, including parts and labor. There are three main methods to reset the TCS light. The first method uses an OBD scanner to clear fault codes and perform a system relearn procedure. The second method involves disconnecting the battery. Disconnect the negative terminal for 15 minutes, then reconnect and allow the system to reinitialize. The third method is a manual reset using the TCS button, though this is not available on all vehicles. Turn ignition to on without starting. Press and hold the TCS button for 5 seconds. Modern vehicles integrate TCS with advanced driver assistance systems like lane keeping assist and adaptive cruise control. This means TCS issues can affect multiple safety systems. Electric vehicles add another layer of complexity, integrating TCS with regenerative braking systems and individual wheel motor control for enhanced traction management. Remember that successful TCS troubleshooting requires systematic diagnosis. Start with basic checks, use proper diagnostic tools, and understand that modern systems are increasingly complex and integrated.